6 is irrational and complex numbers. And in section 6.1, we're going to talk about the roots of real numbers. And to start it off, we're just going to basically define or talk about what a square root is. And anytime that you think of a square root like the square root of 36, you think of what times itself will give you 36. In order for a square root to come out as a negative, they will write that negative out in front of it. So the square root of 36, if I want that answer to be the negative square root, then you would see that negative out front of it. So just going through and doing the very first ones down through problem number 6, if we think of the square root of 9, the square root of 9 is 3 times 3, so the square root of 9 is 3. And as I showed up above, if I have a negative out front, the square root of 9 is going to be 3. And then this negative just basically means that that answer is going to be a negative. When we get into cubed roots, if we have like the cubed root of, let's say, 27, I have to think what times itself 3 times is going to give me 27 in order for it to be a perfect cubed root. So the cubed root of 27 is 3. So if I'm thinking of the cubed root of 8, I have to think what times itself 3 times will give me 8. And that's 2 times 2 times 2. So the cubed root of 8 is going to be 2. So on problem number 3, if you have the cubed root of negative 8, what times itself 3 times would give you negative 8? Negative 2 times negative 2 times negative 2. So my answer is going to be negative 2. Notice that if you have an odd index, and this 3 is called the index number, if you have an odd index, you can have a negative underneath that radical. But if you have an even index, and that's a 2, it's just not written on square roots, this is not possible. It's called not real because there's nothing times itself that's going to give me a negative number. So going to problem number 4, if we're talking about a fourth root, if my index is a 4, then I have to think of what times itself 4 times will give me 81. And this is where knowing our perfect cubes and fourth roots really comes in, because this is 3. So 3 times 3 times 3 times 3 will give me 81. So the fourth root of 81 is 3. And on problem number 5, I have an even index. There is no way I can get 4 numbers to multiply to give me a negative. And so this is a not real. There is an answer to it, it's just not real. And problem number 6, the fifth root of a negative 32. If I have an odd, then this is possible. This is the fifth root of negative 2 times negative 2 times negative 2 times negative 2 times negative 2. 5 negative 2's will give me 32, so the fifth root of negative 32 is a negative 2. Now before we jump and do problems 7 through 12, I want to go down to the bottom because I want to talk about properties of radicals. And these are some properties that are pretty important to kind of grab a hold of. If you have like the nth root of b and is raised to an outside nth root, we can take the shortcut and go, okay, this nth root and this n cancel each other out and just give us b. So if I have into example number 1, this square root, the square root of 9, if you want to go the long way, the square root of 9 is 3, and 3 squared is equal to 9, or a square root and the power of 2 basically undo each other. And the same thing with the cubed root of a negative 3. The cubed root of a negative 3, a cubed root, and a third power basically cancel each other out. It's when you have your exponent on the inside of your radical where it all depends on if your index is odd or even. If it's odd, then it follows this same rule, that these basically will cancel each other out. So this would just give us b. So here, the cubed root of 8 cubed is just going to give us 8. The fifth root of a negative 3 to the fifth root is just going to give us negative 3. But here is where you have to be careful. What if my index is even? If your index is even, the only way that you can have a negative answer is if a negative starts out front. Like we said, this negative square root of 9 is equal to a negative 3, but the square root of a negative 9 is not real. You cannot have an even index and have a negative answer unless it starts out negative out front. So we have to make sure that if we're going to write the nth root of b to the n, it is the absolute value of b. Okay, what that means is you have to have a positive answer. So here we can't just simply say, hey, I'm just going to cancel out the square root and the 2 and get a negative 3. It's an even index. I cannot have a negative answer coming out of an even index unless the negative starts out front. So you can either think of it as the square root of negative 3 squared, which is 9, and the square root of 9 is 3, or according to this property, it is the absolute value of negative 3, which is just 3. Here, this fourth root, it's an even index. These are not just going to cancel. I've got to either think of it in terms of I have 4 negatives, which is going to make this a positive, but I don't know if h starts out as a negative or positive, so I can either write either absolute value of negative h or the absolute value of h. I've just got to make sure that this comes out positive. So if we use these properties up on the top on problems 7 through 12, here I have an odd index. So I could just simply go, okay, the cubed root and the third power cancel out and give me 8. But here, if I have an even index, I cannot just cancel and say I have negative 2. I have to think of this either as the absolute value of negative 2, or most people will just go, hey, negative 2 to the fourth power is 16, and then the fourth root of 16 is positive 2. An even index has to give you a positive answer. On number 9, if we have a variable and we don't know if it's negative or positive, then we have to think of it in terms of absolute value. The squared and the square root are going to cancel, yes, but I have to put the absolute values on x to make sure it's positive. Okay. So when we get down to problems 10, 11, and 12, I'm going to show you kind of a shortcut. And it's a shortcut. You can either think of it, if I'm taking the square root, I can think of it as x cubed times x cubed, which is going to give me an x to the third power. But here's a shortcut that if you have a radical and you have an exponent on the inside, you can change this to a fractional exponent and take inside over outside, and this is x to the 6 over 2, which is x to the third power. Because it's an even index, I've got to make sure to put absolute values on that to ensure that it's going to be positive. So here, if I change this to a fractional exponent and take inside over outside, so 15 over 3, I end up with x to the 5th. Because it's an odd index, I don't put absolute values on there because it could be negative, and that's okay with an odd index. On number 12, inside over outside, 6 over 3. So this is 10 to the second power. If I actually can solve that and take it out to a number, I'm going to do that. The cubed root of 10 to the 6th is equal to 100. Let's cut that off. So on 12b, inside over outside, 4 to the negative 3 over 3 is 4 to the negative 1. And we know from last chapter that's equal to 1/4. So just keep in mind that in even index, you have to ensure that your answer is going to be positive. The last part of section 6.1 is going through and doing equations. And in the last chapter, we would always take any kind of quadratic, set it equal to 0, factor, and then end up with our 3 and -3. We're going to approach it a little bit differently. When you are, I'm going to rewrite this, when you have a perfect square, like x squared, y squared, m squared, the other way you could do it is taking the square root of both sides. When you take the square root of x squared and you have the square root of 9, when you are solving equations, you have to consider that x can be either a positive or a -3. Okay. So in equation solving, like on number 14, if you're going to square root both sides in order to solve this equation, you have to consider that x could either be a positive 6 squared or a -6 squared. So this is going to be equal to positive or -6. And again, go back to when we talk about quadratics. If you have a quadratic and the highest exponent is 2, that means you have 2 roots. On number 15, the last one, if I square root both sides, I cannot take the square root of a -9. So if I can't take the square root of a -9, then I'm just simply going to write not real. Don't put no solution because it does have a solution. It's just not a real solution. So we're going to just for now say not real till we get to imaginary numbers, and then we'll have a solution for it.